Hi, everyone. I see some people starting to come in. If you're coming in, feel free to drop your name and where you're from in the chat. We'll be getting started in about 3 to 4 minutes. Hello, Lee. I feel like I've connected with you in a couple of other sessions already. So as you're coming back from our short break, if you want to go ahead and drop where you're from in the chat, introduce yourself, maybe share something that you've learned thus far that has been particularly exciting to you. I'm really excited about Boot Up PD that, or just Boot Up, oh, hold on. Yeah. Boot Up PD and some of the resources that they have there. I'm excited to explore that a little bit further. And in the first session I was in, I was really interested to learn a little bit more about the Scratch resources with everyday math that Diane shared. I'm hoping I'm saying this all correctly. Hello, Chris. Hello, Cynthia. Lots of Indiana people. I think that's been mentioned multiple times. I am from Ohio, Cleveland area. It's actually sunny here right now, so I will take it. Welcome back from our little break. Go ahead and drop your name and where you're from in the chat. Maybe share something great that you've learned thus far in our first unconference session and the first anchor session. Deborah, Angela, hello. Renee, hello. Hi, Julie. We're going to give it another minute while people are coming back. I was scarfing down lunch in our little break. Hi, Steve. Ooh, blueberry muffins. Cindy, are you doing that while you're participating? I love it. Apparently, I would have blueberry mix all over my computer. It would not be a good idea. Hi, Venus. So I think these sessions were set to start at 12:30, or okay, I'm sorry, I'm Eastern, 12:30 my time, 11:30 Central time. Are we good to get started? Yes. Venus just posted the notes doc, and we're going to go ahead and get rolling. I have quite a few things that I'm going to share today, and several activities that I want to get everyone involved in. So I am really excited to get started and really kind of take a little bit of a different approach than all those amazing resources Diane shared in the morning elementary session. And we're going to look at that approach of, but I'm not a computer science expert, and really addressing that. And I think we heard in some of the other discussions this morning about the importance of approaching that with elementary teachers. So just to give you a little background on myself, I am currently the coordinator of instructional technology in the North Olmsted City Schools, which is in Ohio near the Cleveland area. My Twitter's on there. Feel free to reach out to me on Twitter. And a little bit about me. Before I took this role, I've taught 2nd, 3rd, and 4th grade. I'm involved with Google stuff and InfoHio, which if you're an Ohio person is a phenomenal resource. I'm passionate about STEAM integration. I love Star Wars. And guess what? I am not a computer science expert either. I don't have a degree in computer science. And if you would have asked me 6 or 7 years ago when I first started exploring computer science, I had not the first clue in the world what it was, how to integrate it into my class, and I've grown over time. So I want us to really keep that in mind as we are going through today's session. To get us all started, I want to engage our audience a little bit. So all of you, if you have, I want you to think about one fear you have, something you feel comfortable sharing, and go ahead and drop that in the chat. What is one thing that you are afraid of? Maybe it's a funny fear. Maybe it's something that just paralyzes you. Being buried alive. Yeah, Cindy, I can see that. Fear of failure, overtaking a space unintentionally, not doing enough snakes, getting in over my head. Many of you are sharing fears that I definitely have. Especially that fear of failure, that fear of getting in over my head. I would say one that's a little bit different is I am scared of ice cream trucks. I find them very creepy. So that's kind of a little bit more of a funny fear, but I want us to keep that in mind as we kind of journey forward. And I want us to think about how for many educators, especially at the elementary level, there's that fear of, okay, I'm already scared of technology, or I'm bad at technology, and now you're throwing this computer science at me. How do we approach this very real fear that so many elementary educators have, not feeling like they are an expert in computer science or lots of other things? And so oftentimes we avoid it completely because we have that fear. And so as we're going through today, I'm going to give you 5 tips, and we're going to do some activities with those tips about how we can help address that fear and begin to make elementary educators feel a little bit more comfortable in adding and incorporating and embedding computer science concepts to their classroom. So my first tip is to make connections. I want you to think about today, how can we help educators make connections between standards? Now, if you're an elementary educator, you probably already do this with just your content areas. I know when I was teaching 4th grade, social studies and language arts oftentimes married themselves together very well. We would read and analyze texts about a lot of these social studies concepts that we were learning. Another thing that I've done in my current role is, because I'm from Ohio, I was thinking about how can I actually look at the standards ahead of time and prepare something for teachers so that they could begin to see some of those connections. Because as I learned when I was working with different teachers in our district, many of them didn't naturally see some of those connections between the technology, the computer science standards, and their other content areas. So this is going to be in the slides. I'm going to share the slides with you at the very end. But I started with just taking all of these major areas that we might be exploring at the elementary level and mapping out where I saw the connections. And so for this particular document, I actually was looking at the domains and topics. In Ohio, our standards are organized by domain and then the topics, and started tying things together and where I see those subjects naturally integrating. And sharing this information with educators gave them a chance to start thinking about their standards in a different way. And so we looked at how the informations and communications technology standards might tie in with some data analysis or computing systems, or even looking at the impacts of computing. And then where might this integrate into other subjects? Now, this isn't an end-all be-all, but it's a starting place. And so if you are an individual who works with teachers, or you're very passionate about this, how can you look at all those standards that are presented to you, look at the things from your state, and begin making those connections that you can share with other people? I looked at how we have more informations and communications technology standards, and they connected in my brain naturally with networking. And I begin to see how that might connect with how we present or how we're writing, looking at organization. One area that I really saw a lot of connections was between social studies content and some of the society and technology standards, or looking at the impacts of computing. And so I began to see how I could naturally marry some of those things together. And so I'm going to click through the rest of these. And again, you'll have a chance to go back and take a look at these. But I want us to engage in our first activity, and it's really just to make some connections and do this in a collaborative way. And so what I'm going to do is I'm going to drop a Padlet link in the chat. And if you go ahead and go to Padlet, what I've done is, because we're multi-state here, I've taken the standards from CSTA instead of a specific state. And I've taken the concepts, sub-concepts, and the standards for really that K2 and the 3-5, and put them in a Padlet. And so you'll notice that we've got the concept of devices, or the concept of computing systems, and the sub-concept of devices, and then the standards for devices. And what I want us to do is take the next 5 minutes and add to this document, where do you see connections with things that are already happening in the elementary curriculum? I've already started a few. For example, with the algorithms, I wrote, instead of writing a list of rules for checking out a book from the classroom library, we created an algorithm for doing so. We role played to determine how effective our algorithm was and what we needed to add to it. So I'm going to pause myself from talking for the next 4 minutes and ask you all to hop into this Padlet and add some of the natural connections you're already seeing. You don't need to know everything about that standard, but where do you already see natural connections? Is everyone able to engage in the Padlet? Is there anyone who's not able to click in and comment in the Padlet? Cindy and Lee, what I would encourage you to do is maybe just start at the top. Don't scroll down any further. Just start at the top and see if there's something in there that makes you think of something else. I see someone added under network communication and organization, taking a project, breaking it down into smaller parts to finish at different times, then pulling the whole thing together at the end. Yes, that's an awesome way to do it. And I think many of us already do that in our classrooms as we break down information for students. There's no wrong way to make connections. Yes, many of our ELA stories have different examples of technology, past and present. That's an awesome way to approach that. We pulled apart some old technology in a lesson on circuits that I did with students. And so I actually had parent help and we took apart a VCR. And that was very interesting. Many of the students had never had exposure to a VCR before. Students search and retrieve information and text naturally in ELA. Under storage, looking at algorithms, we could create and conduct an investigation in a science fair. Control, looking at Scratch Junior is a great way to address loops and events and sequences. I see Steve has a suggestion in the chat about when teaching integer long division. I was wondering what it'd be like. So by presenting it as an algorithm, references to sequences, selection, iteration. Let's see. I'm going to add that in here. Thanks, Steve. So in the interest of keeping us moving, I'm going to leave this Padlet as a working document that we can all come back to, and you can feel free to reference later or continue to add to it after this conference or maybe during the next unconference session. And I want to kind of take a step into our next tip. So our first tip is to make connections. We really need to help educators see how what they're already doing connects to so many of the computer science standards, and they can easily incorporate those computer science standards in what they're doing. And our next tip is to build on vocabulary. I find that, first of all, I don't know a lot of the more complex vocabulary associated with computer science, but there are a lot of computer science terms that so easily connect with what I do in the classroom. So for example, I'm thinking of loops. And loops makes me think of repetition. And I teach repetition when I'm teaching poetry and I'm talking about how an author uses repetition. We talk about how authors might repeat things in text, and that can really impact the way that we interpret the text. I might look at repetition on a timeline and see how things have repeated themselves over time. And so I want you to really think about what computer science vocabulary is out there that you can share with other educators that so easily connects to things that they are already doing. So here's our next little activity that we're going to do, and we're just going to use the chat to do this. If you already have some vocabulary in mind, you can go ahead and drop that in the chat. Otherwise, I am going to attempt to share this link. Of course, I pasted something else. There we go. Copy link. This is the link to CSTA's glossary. And so what I want you to do is take a look at the glossary and look at the vocabulary words in there. And what vocabulary are you noticing already connects with things that you are doing in the classroom? So I'm going to pull up that vocabulary right here. I had a great experience with a teacher last week. She did her first unplugged programming lesson. And when I had come into her classroom, she stopped and she had the kids share what they had learned. And they'd been talking about events. And we quickly tied events to building routines in the classroom and made that connection. But realizing that we use events specifically in programming to mean a certain thing, but we can take that understanding and apply it to other things in the classroom. Ooh, decomposition, Marissa. Yes, decoding words is huge. I see arrays in here, which it looks very different when I get into the world of actually utilizing those data structures and comprising a collection of values. I think of more arrays in the complex math that I did in some calculus classes. But I also think of arrays in elementary when we learn how to multiply and how we create arrays and collect things. Artifacts. Algorithms, a series of steps. Yes, we were talking about how algorithms the other day in a third grade class, how so much of what we do is in an algorithm. We don't think about it that way, and we naturally infer steps. But it's that same process of going through that series of steps. Bugging, debugging, finding mistakes and correcting. Yes. Data, huge. Problem decomposition. I'm looking to see what else. Computing. Conditionals are actually something that a lot of times we will do in the elementary level. In ELA, we begin to talk about if-then statements and cause and effect. Code tracing, analysis. So there's so many words out there that if we can help educators see that the vocabulary connects to concepts that they're already doing in the classroom, we can further help address some of that fear that educators have and feeling like they don't know the first thing about computer science. They already have some of that knowledge based on the things that they're teaching in their particular class. So another way that I like to really take that vocabulary and hone in on that vocabulary and share it with educators and help to address that fear is through elementary literature. And I put a picture of a series of books that I happen to have. I know in one of the other sessions that I was in, someone mentioned the Hello Ruby books. And there are lots of other great books thanks to just the giant leap we see in the importance of computer science. There starts to be a lot more literature written for elementary students. And so this can be a great way to address that fear with educators if they have a book that explains those concepts not only to students, but those concepts can also be a little bit more, how shall I say, simplified for educators. So if I were to share, for example, this first book here, Train Your Brain with Parallel Computing and If-Then Activities, if I were to just tell a teacher that I wanted to talk about parallel computing and conditionals and if-then activities, I might lose them quickly. But if I can give them a book that's really simplified, does it get fully to what we want students to know? Maybe not, but it's a good starting place. And so sharing some of that literature with educators can be another way to help begin to break down that fear. So my third really, I guess, tip for helping to address that fear is to go unplugged. And this came up in the Unconference session that I was just in with the elementary folks about talking about unplugged activities. And the one thing I really love about an unplugged activity is it takes away the computer and it gives educators a chance to just focus on the concepts. And there's some great unplugged lessons already out there for students to experiment with. And so I'm going to share 2 sites with you in the chat. The first, I believe a lesson earlier came from this, and this is CS Unplugged. And the second is code.org. Both have phenomenal unplugged activities that are a good starting place. And so I had an educator that I had just shared about earlier that she did her first unplugged session with students this past week. I had gone in and modeled in her classroom another unplugged lesson, and she was like, I'm very nervous about this, so we're going to do something super simple. And she actually did this lesson, the Big Event Junior. And she told me afterwards, she was like, it's probably a little too easy for my 3rd graders, but it helped me conquer that fear, and it really helped me better understand some of those concepts that you were talking about when you came into our class and we were working in code.org. So I would take a look at these 2 sites, explore and see what you can find that might help you begin with some computer science activities and really integrating some core concepts. I have shared, and I'm going to share this in the chat as well. This is an unplugged activity that I actually created during COVID for teachers to explore and utilize with students. There were video directions that I had added in here, directions for the teachers, and then directions for the students. And what students were doing is they were actually taking their robots and moving their robots through this game board to get to the finish. And while they were using that activity, they were then recording each of the things that they did. So they have their code blocks down here that they could use, and they were going to pick up certain fractions. So for example, it might be that you are trying to move your robot from start to finish, and your robot needs to pick up all fractions that equal 1/2. And so as they're going through the different options, they're looking for fractions that equal 1/2. Maybe you've been working on how fractions can be equivalent. And so they would then write their steps here. Maybe they're going to move so many spaces, and then this is when they're going to pick up the fraction, or maybe they're going to jump over spaces. They can move in these different directions. So these become your blocks of code. And whatever goal you want is determined by you, the teacher. The great thing about this activity is the way that I saw it is, okay, I could do this with fractions, but I could put anything else on this board. If you're a primary teacher, you could even put pictures of words. And you could simplify the board. You don't need this many choices on the board, but maybe they're picking up cards that start with the letter A. that has an object that starts with the letter A. So how are you introducing some of those computer science concepts to students, but still having those meaningful connections with the other content that you're already teaching? So when you look at this activity, you can go so many different ways with this. And the thing is while you could do this in Google Slides, all of this can be printed and students can do it without the computer as another distraction. So how can we create those meaningful opportunities with computer science, unplugging from the computer? And it really gives us a chance to look at the concepts and not so much worry about all the different blocks of code that we have to arrange in a certain way in the program. So what I want to do is I want to take a moment and I want you to look at one of these 3 unplugged resources that I've just shared, whether it's CS Unplugged, code.org, or this game board. And I want you to share out what's something you found in one of these resources or something that you're thinking about that you might be able to do unplugged with your students. So we're going to take about 3 minutes for you to explore some of these resources. Another activity I really liked, I'll share in this code.org unplug, was this My Robotic Friends Junior. I actually did this in some professional development where I was a participant, and we moved these cups and wrote our algorithm to stack cups. And we had a lot of great discussions as adults. Get loopy on code.org. Leah, is that something you've already done or something that you're thinking about? Oh, okay. Make some binary bracelets. Lessons on code.org. Haven't done unplugged yet. I do think that sometimes unplugged takes, well, it takes a little bit more planning because you've got to prepare the materials. But I think it's a nice, easy in for educators that are a little bit nervous about beginning to program on a computer and feeling like you don't have all the answers to students. That Unplug kind of took that pressure off. We didn't have to worry about if everything was exactly the right answer. It was more about the discussions and making those connections together. So I want to journey on to our 4th tip or strategy, and it is to start small. When you're first starting to explore computer science, especially at the elementary level, I feel like you need to find your niche and go from there. So find that little window that is your in. Maybe you're saying all this algorithms is too much for me, or maybe you're the person who's facilitating training with teachers, and you're hearing teachers are very overwhelmed by all of the algorithms and writing programs. Now, I know many people think that computer science is synonymous with coding or programming, and that's just a small piece of computer science. But I'm thinking about how many teachers might already do some of this impassive computing together, and they might be thinking about this in their lessons or even making the connections with digital citizenship. And so celebrating those successes of you're already integrating computer science concepts when you talk about culture and technology, when you're talking about how we worked respectfully online, that's beginning to touch on some of those concepts as well. So helping educators see that it doesn't just mean you're pulling out a computer and you're programming, or you have to have fancy robots. Vino's talked about, just posted in the chat about unplug lessons, their go-to activity during indoor recess. I love that. So having those opportunities to connect in those small ways are so important. And so I am sharing a few resources, and some of these you're going to be very familiar with. But what I've encouraged teachers to do, and Lee mentioned using the code.org resources, is I've encouraged several of my teachers to do code.org, do the course with your students, or do it for fun on your own. So you don't need to start with some high-level programming course that's going to jump right in. It's okay to do the elementary course and figure it out as you go. If you want to talk about some of those impacts of computing, Common Sense has done a lot of great things with their resources. CSTA has curated some great PD. Lee mentioned about playing Interland, which is by Google, and that has some good cybersecurity stuff for students. I will say, Lee, I tried to play that one day myself, and I felt very silly. I might have gotten stuck in Interland. I couldn't figure out how to move further. And then the other thing that we can do is we can consider how there are already connections in some of the things that we see in maybe Scratch with many of our content areas. And so I'm sharing these 4 different documents with you. These are things that I have put together. The last one here, and then I'll open one up and talk briefly about it. So what I've done is I started to look through and think about Scratch and Scratch Junior, specifically in a math class. And where could I see either one of these being integrated and thinking about math? Might I do a whole group to build a program to illustrate a concept? So maybe we're building a program together, or maybe we're discussing certain blocks that illustrate new concepts. Pair programming, open-ended math challenges, illustrating a story problem, solving a math problem, illustrating a proof, geometric concepts, building games. Maybe it's an option on a choice board for a math project. Maybe I'm sequencing steps within an algorithm or delving deeper into understanding algorithms. So I can look at some of the things I can see in Scratch this way, and I can also begin to look at just some of the blocks. So the beautiful thing of working in a program that codes with blocks is they're very visual. And so maybe I'm not yet building a program, but I'm just exploring some of the different blocks with students. So I have here where I am in Scratch Junior, and I'm looking at that coordinate grid that I have. Maybe I'm using operators and thinking about my different operations or inequalities or Boolean logic, variables, angles, coordinates. There's so much I can do with just looking at some of those visuals that I have inside some of these different programming tools. And then the other resource that I think sometimes is a little untapped is look at your local library listings. I've been very impressed lately on how many things our local library is providing to help adults and students explore computer science. And so I recently hopped into some things at our local library, not for computer science, but I learned how to use the CNC router, and they taught me how to do it. And that was an awesome opportunity for me to, one, engage with the community, but two, learn about something for free. Julie, I love that, that you're working on a grant to connect computer science and libraries. If you want to share more in the chat, I'd love to hear a little bit more about that. So what I am going to ask you to do as our little activity here before we go into our very last tip is I want you to take one of these resources that I've just shared out in the chat and explore it. And I'm asking you to share one little nugget that you took away from this resource. Maybe you found something that you're going to now explore yourself. Maybe you went to your public library site and found that they offer a course that you can take. What things are you noticing? Building awareness and building community around computer science in rural communities. Wow. That sounds impressive, and I really hope that you are able to get that grant. Sharing the different subject areas. I will say, and I wish I would have had the time to take advantage of it this summer, but code.org actually offered some free longer boot camps for teachers. It would have been down in the Columbus area, but it was a whole week where they actually went through their resources and were supporting elementary teachers, and it was paid for by grant money. So as long as you could get yourself to Columbus, there was no cost for you to be involved in that. So I strongly suggest looking at some of those resources. There's, I think, a lot of phenomenal free PD available for teachers to really help you begin to understand some of these different concepts. I'm going to drop this. I heard this in one of the other sessions, and I haven't explored it a ton yet, but that bootuppd.org looked like some great things as well. So, so we don't run out of time, because I do want to give you a chance to explore in a challenge. Is my last tip is to challenge your brain and think about how can you challenge learners to create and explore in small doses. When I'm working with teachers, I felt like sometimes they were very overwhelmed by like a full out doing a whole unit of computer science initially. And so my inroads was often through very small challenges. And so how can we create activities that really are open-ended? They're those high ceiling, low floor activities that all students can access regardless of their entry level with computer science and other concepts, but things that are going to be, they are kind of a little bit one-off activities, but it's a great chance to get teachers thinking. And the thing I love about some of these different challenges that I've done with teachers is they have been an opportunity for me to have them be a student with their students. And so teachers were able to model how they're learners as well, and think about how the learning that they get from these different activities could really support their students. And so I had another link in here. I'm going to grab it from my other version. Oh, and of course it doesn't want to copy paste. So here's what we're going to do. We are going to, I think, oh, no, here we go. Okay, so we have this Scratch activity that I have just posted in the chat. And if you go in there, you'll see that what I've already done is I've already chosen the backdrop and laid out the blocks for students. And my challenge for the students was simply this. How can you determine the perimeter of the chalkboard using Scratch? And so we talked about some of the different blocks that we might use. And in fact, I gave them some of the blocks to get started because many students had never done any programming at all. And so they began to lay out some of the different blocks, and we talked about what we knew about perimeter and made that tie with perimeter. And I actually had, and I don't have it with me, but I went to the dollar store and bought little animals. And we did this on paper first. So our animals were our sprites. And we actually wrote an unplugged program where they were coding their animal to walk the perimeter around a rectangle that they drew on the paper. And so making those connections with what perimeter means, and then bringing in that computer science concept. And so we utilize the pen tool, we utilize different blocks in order to go the perimeter of this chalkboard. And I was pleasantly surprised, almost all the students figured it out. And then we took a step further with the teacher as the teacher figured it out. And okay, so when I'm looking at students' programs, what am I noticing about their program that shows that they understood the concept of perimeter? Well, I quickly had some students use the repeat block, and they repeated it 2 times. And when I asked, not 3, 2 times, and when I asked the student of why they did that repetition, the student was like, well, I know that 2 sides are the same length, and so I need to repeat this 2 times. And so we kind of began to transition to 2 times the length plus width. And so making those connections and going a little bit further, in one class, we actually did a square. So I had a different backdrop that was a square. And students quickly were like, well, a square has 4 sides. I can do this 4 times because I know that 4 times that length, it makes that perimeter. So making those connections in that way was another great way to do that. So I'm going to share, you know what, I'm going to share this whole presentation at this point in the chat. I know I've got some other people who have dropped in some comments that I want to go back and address. But I want to take a moment to answer any questions. We have about 8 minutes left. And so in those 8 minutes, I want you to take a look at what you find, some of the resources that were shared, whether in the chat or in the presentation. And if you have any questions, feel free to drop those in the chat and really just open this up to some discussion about how we can help address and begin to tackle that fear of computer science so that our students can have those rich, rewarding experiences that we know they're going to need as they enter the workforce someday. Renee was talking about that sorting network. Yes, Renee, you shared that earlier. King size flat sheet. I was going to do that activity, and then I was just overwhelmed by drawing it on the concrete outside, and I didn't do it, but that would have been a great way to do it. And I could have gotten a king size flat sheet from like Walmart or the thrift store even. Scratch and Scratch Junior resources. Steve mentioned the curriculum from code.org. Paula's been adding notes to that notes document linked at the top of the chat. Oh, yes, there it is. So many awesome resources people have shared. I know another one that I had lots of fun with the middle school students is I first went in and we did the artist lab tutorial from code.org. Let's see. And so we went through this and actually programmed each step of the way where they learned how to use that artist lab. And it was some great connections between art and math. And it was really interesting to see the teachers work through this initially themselves and struggling, but processing how the character is turning, how your sprite is turning, and how you need to manipulate your sprite and where angles are coming in. And we talked about the ties to geometry. So this was a great experience for those students as well. Thanks, Clark, for popping in. Is there anyone else that has any questions or anything else that they want to share as we wrap up? We've got about 3 minutes left in our session. Code/art.com. Ooh, I haven't seen this, Paula. I'll have to take a look. That looks pretty cool. Pixelart.com, pixel art and graph paper, teachable machine. Thank you, Susan, for coming today. Code.org now has lessons that integrate CS connections. That sounds exciting. So what I want to challenge you all today as you leave and go into our last unconference session is to think about how you might address any fears that you have with computer science, how you might make connections, start small, maybe go unplugged, and how can you help other educators around you, whether you work directly with teachers or you just have a team of teachers that you work with? How can we help all educators feel that they can begin to take baby steps with computer science and realize you don't have to be a CS expert to begin to give your students some of those opportunities?
Hey, thank you so much. This was wonderful.
Thank you very much for moderating and collecting everything. And
no problem. I don't think I really had to say anything. You took care of it all. Excellent. Lots of resources. Love it.
Yes.
Okay. All right. Jason just mentioned that it's time for a break if you would like. If not, you can go to the networking. The networking is kind of a cool experience. You basically go in and they match you up with people that have similar levels or who they suggest you might want to try talking to, and you get a like a 5-minute conversation. So it's kind of a neat way to meet new people. So give it a shot. Okay, other than that, I think we've got a few minutes yet, and then they are going to repopulate apparently around the 25-minute so that we can get back into the next 30. Okay.
Sounds good. I'll hang out here for another minute, and if anyone else needs anything else, just let me know in the chat. Otherwise, have a great rest of your conference.
Okay. I'm going to take off and take a break.
Sounds good.
I will see you later.